A new type helicopter has been developed by the Bell Aircraft Corporation. Incorporating important new principles of rotary wing design, the major features of this helicopter include its stability in flight, simplicity of design, and precision control. Developed as part of the company's overall war program, the Bell helicopter is expected to have many important applications in post-war transportation, both commercial and private. For more than 15 years, Arthur M. Young, designer of the Bell helicopter, conducted extensive research in the design of rotary wing aircraft. Carefully constructed models were used for all early experiments. The first of these achieved flight, but lacked stability, could not be controlled. Directing all his attention toward the problem of stability, he later tried various types of hinged blades. Although the model flew, it developed an unstable swinging motion in still air and would not hover. The next step was a major improvement, an independent rotor with fixed blades. The plane of rotation was maintained regardless of the rotor mast position. It had good characteristics in still air, but proved unstable in the wind. Not until an entirely new principle was tried in the form of a stabilizing bar or artificial horizon to govern the rotor angle was the answer to the stability question found. The resulting combination flew so successfully regardless of the wind condition that basic stability seemed to have been achieved. Climax to these years of research and experiment was a final model complete with controls operated electrically from the ground. In still air or moving air, this model proved the stability principle to be practicable and effective. The design was ready for full-scale construction. In 1941 at Bell Aircraft, the work of building a full-size helicopter was started. Patterned after the control model, each engineering detail was worked out with great care before construction was begun. A small group of technicians was assigned to this work, and the entire project was carried on independently of the company's other operations. In the small shop, the workers readily adapted their skills to the construction of this new type aircraft, and in less than a year, the first ship was ready to fly. No vast airport was needed for this flight test. The small yard behind the shop would do, for with its vertical takeoff, the helicopter needed only a space large enough to provide clearance for its 33-foot rotor. The lifting forces were found to be satisfactory, and the stability characteristics present in the small models were confirmed in full scale for the first time. Control response was prompt and reliable. In charge of this flight test program was experimental test pilot Floyd Carlson. For him, this was a new experience. Unlike Bell's high-speed fighter planes, the helicopter gets its lift from the revolving blades, needs no forward speed to sustain it in flight, can fly at 0 miles per hour. Although little attention was given to high-speed performance at this time, the new ship's speed compared favorably with that of smaller light aircraft, covered ground much faster than an automobile. Here was promise for a new kind of cross-country traveling, with no need for roads, no airports for safe landings. While the flight testing program on the first ship was in progress, a second helicopter had been completed. This model incorporated a number of advances in design, had an all-metal body with enclosed cabin. Designed for maximum visibility in the directions desirable to this type aircraft, the cabin curves outward at the pilot's eye level and has large areas of transparent plastic glass. Automobile-type doors and roomy cabin add to the occupant's convenience. The instrument panel is simple, having a minimum of flight instruments. There are dual controls, and a conventional stick governs the direction of travel by tilting the rotor cycle plate at the base of the mast. When the stick is pushed forward, the rotor blades tilt forward, and the ship travels in that direction. For backward or sideward flight, the stick is moved in the direction desired. Beside the pilot is the control for rising and descending. When this lever is moved up or down, the blades change pitch, giving more or less lift as required. Foot pedals, similar to those on conventional airplanes, control the small anti-torque propeller, which serves much like a rudder. By changing its pitch, the helicopter will pivot, turning in either direction. In starting, when the motor is up to speed, a clutch automatically engages and the rotor starts to turn. Compactly built for two persons, the helicopter carried as its first passenger Larry Bell, president of Bell Aircraft. To this company, whose record is one of innovation in aircraft design, the helicopter is a logical new development in the field of practical aviation. As in the successful model, the basic feature of the Bell helicopter is the combination of the two-bladed rotor and stabilizing bar. The rotor blades of solid wood construction are reinforced with steel and revolve about the mast on a special hub mounting which is coupled to the stabilizing bar. Acting much like a gyroscope, the stabilizing bar serves as an artificial horizon for the rotor and permits normal operation in strong air currents or gusty winds. Of particular importance for safety is the automatic freewheeling mechanism incorporated in the engine transmission. The helicopter will land safely by auto-rotation of the rotor blades should there be an engine failure. The stability and precision control which characterize the Bell helicopter are important to the handling qualities of rotary wing aircraft. Added to this is its versatility, its ability to fly backward or sideward just as easily as it will fly forward. The pilot has only to move the control stick in the direction he wishes to travel, and the ship responds promptly. The helicopter can be flown effectively in restricted areas. Quick to respond, the ship is sensitive to the slightest change of controls at low or high speeds. The helicopter can be made to pivot in either direction by operating the foot pedals, which govern the pitch of the anti-torque propeller. With the stick in neutral position, it will hover over one spot, its stability undisturbed by air currents which normally affect other light aircraft. The precise handling made possible by the various controls achieves in the helicopter a high standard of safety, since this craft can take off, maneuver, and land without the high forward speeds usually associated with flying. It has been said that helicopter transportation requires no subsidies. It can be operated without benefit of expensive runways, airports, or terminal facilities. With the helicopter's vertical landing and takeoff, passengers and cargo one day soon may be brought directly into metropolitan areas landing on top of buildings, or in a space no more elaborate than the average automobile parking lot. On the evening of July 4th, 1944, in the Civic Stadium at Buffalo, New York, the Bell helicopter had its first public demonstration. With wartime necessity canceling their usual Independence Day holiday, more than 42,000 spectators, mostly workers from Buffalo's war plants, witnessed the flight of the coming thing in aviation as part of their July 4th celebration. Before the crowded stands, the helicopter, with Floyd Carlson at the controls, carefully found its way past guy wires, loudspeakers, and fireworks displays to give the audience a close-up of what may well be their transportation of the future. Flying in restricted areas was not new to the Bell helicopter. For 2 months earlier, it had flown inside the 65th Regiment Armory in Buffalo. This was the first indoor flight ever made in the United States. The demonstration was arranged at the request of the United States Civil Air Patrol, wartime organization of civilian aviation enthusiasts keenly interested in everything new in aircraft. Exhibiting the helicopter's ability to maneuver in close quarters, Carlson circled around the designer, Arthur Young, for a spot landing on his outstretched hand. Then, descending vertically to a gentle landing on the armory's floor, the Bell helicopter had shown that it could take off, maneuver, and land in the most restricted areas. Sharply contrasting the flight conditions indoors are the winters of western New York, which provide flying conditions at the other extreme. Through snow and sleet, with ceiling and visibility nearly zero, conditions which normally paralyze all air traffic, the helicopter at easy, controllable speeds carefully flew its course despite the blizzard with complete safety. Flight conditions such as these, which ground conventional airplanes, have become known as helicopter weather. The extent to which helicopters will someday play a part in the everyday pursuits of the peoples of the world has not yet been fully explored. It is not expected that tomorrow the skies will be filled with privately owned helicopters, but their eventual usefulness to modern living is assured. In these first ships, the new principles of design unique to the Bell helicopter proved an important step forward in the development of rotary wing aircraft. With extensive research bringing further advances in design and engineering, new and improved models are constantly being put in work, both on the drawing boards and in the shop. Although much remains to be learned about the eventual scope of this kind of aircraft in terms of size, speed, and load-carrying capacity, the Bell helicopter is a practicable aircraft of a type that will have an increasing role in expanding aviation horizons.